So one of my favorite tools for visualizing vector fields is this applet called the Vector Field Analyzer 2. I don't know if there was a Vector Field Analyzer 1 or if the world ever saw it, but the Vector Field Analyzer 2 was created by, I think he might have been a grad student or a postdoc at the time. His name is Matthias Kawski at Arizona State. Anyway, and he built this, I think, probably 15 or 20 years ago. And so at the time that it was built in a Java applet infrastructure instead of something fancy like GeoGebra or Desmos or whatever. And so he had to do all the code for all of this stuff on the back end by hand. And so it's quite an accomplishment. Not only does it give you the ability to just type in the components of a vector field down here in these two boxes and then click to plot this field to sort of show us what the vector field looks like, but it also has a bunch of other tools for visualizing other aspects of what a vector field is. So I talked briefly in our introduction a minute ago about quantities like circulation and curl and divergence and stuff. And so there are what he calls lenses to be able to look at those things on an individual sort of place-by-place basis. And also to look at the differential equations and flows aspect of it. And so what we're going to use this to do in just a minute is to study the integral curves of a vector field. Integral curves are the parameterized curves that follow the arrows of my vector field. So the velocity vector of my curve is exactly equal to the value of the vector field at that point for each point along my curve. So for example, to use this tool, if we go into the DEs and flows tab over here and click on integral curves, what it lets us do is click some points here in the XY plane. And then when we press the stop and go button, it'll trace out the curves that follow those arrows using the points that we clicked as the initial positions, like the initial locations. It's using this Runge-Kutta fourth order approximation. So it is basically just at each point looking at which direction does the vector field point, and then it follows that direction for just a little tiny step. And then it looks again, where is the vector field pointing now? And then it follows that arrow for just a little bit, and so on and so on. And it's called Runge-Kutta fourth order because it's actually making a bunch of approximations to that vector field, not just at the point, but also at some nearby points. And so it gets sort of as accurate of a approximation to following exactly the vector field arrows at each point. Anyway, so this is going to be a tool we can use to visualize those integral curves that follow the arrows of our vector field. So in order to run a Java applet in Google Chrome, you just need to get your hands on a free add-on, a free extension to Google Chrome. The one I'm using is called ChirpJ Applet Runner. We'll drop a link to this in the chat right now. If you'd like to install this in your Chrome, you just have to hit this link, and then your button here will say install rather than remove from Chrome, because I already have it installed. And so what this will do is give you the ability to run Java applets inside of your browser window. And so what will happen then when you come to this page that's linked is it's going to look like nothing is here. But if you go up into your Google browser extensions, it looks like a little puzzle piece. And then just click on ChirpJ. It'll give that extension access to the Java applet that's on this page. And then after a brief period of loading, it'll pop up and you should be able to use it. So this, for me, because it does so many different things to help analyze vector fields and also the integral curves and equipotential curves and all kinds of other stuff associated with a vector field, it's a wonderful tool. I think I've used it every semester that I've taught multivariable calculus since I began my teaching career, because it's been around that long. And I haven't seen another tool come along that does quite everything that this tool does. So congratulations to Matthias Kawski if he happens to ever run across this video. This is a really great tool, and I'm really grateful to have it.